Welcome back to the workshop. Today's project is the complete inspection and restoration of heavy-duty 8-cylinder truck piston ring sets. Although piston rings are small components, they play a vital role in the performance, efficiency, and reliability of a diesel engine. Without properly functioning piston rings, the engine cannot maintain compression, control engine oil, or produce its full power. In this project, we will carefully inspect every piston, clean each component, measure critical dimensions, and prepare the engine for the installation of new piston ring sets. The engine has already been disassembled, exposing all 8 cylinders. Each piston is removed carefully to avoid damaging the cylinder walls or connecting rods. As every piston comes out, it is marked according to its cylinder position. This is an important practice because it helps technicians identify where patterns and ensures accurate inspection during the rebuilding process. At first glance, the pistons show heavy carbon deposits around the crown and ring grooves. This buildup is completely normal in an engine that has operated for thousands of hours under heavy loads. However, excessive carbon can prevent the piston rings from moving freely inside their grooves. When the rings become stuck, they cannot maintain a proper seal against the cylinder wall, leading to compression loss, increased oil consumption, and reduced engine performance. The first step is a detailed visual inspection. Each piston is examined for cracks, scoring, heat damage, broken ring lands, and signs of excessive wear. Even a small crack can lead to catastrophic engine failure if left unnoticed. Fortunately, these pistons appear structurally sound, making them good candidates for restoration. Next, attention turns to the piston rings themselves. Every piston contains 3 rings: the top compression ring, the second compression ring, and the oil control ring assembly. Together, these rings form the seal. Heavy-duty trucks are designed to transport massive loads over long distances while operating under extreme conditions. Every part inside the engine plays a critical role in delivering reliable performance, but among the most important components are the piston ring sets. Although these rings are relatively small compared to other engine parts, they perform some of the most demanding tasks inside the combustion chamber. Without properly functioning piston rings, even the most powerful 8-cylinder diesel engine would quickly lose compression, consume excessive oil, and suffer severe performance issues. An 8-cylinder heavy-duty truck engine is built to generate tremendous torque and horsepower. These engines are commonly found in long-haul trucks, construction equipment, mining vehicles, agricultural machinery, and other commercial vehicles that operate for thousands of hours under heavy loads. Because these engines endure extreme temperatures and pressures, every piston is equipped with a carefully engineered piston ring set designed to withstand harsh operating conditions. A piston ring set normally consists of 3 rings fitted into grooves on the piston. The top compression ring seals the combustion chamber, preventing high-pressure gases from escaping into the crankcase. The second compression ring provides additional sealing while helping scrape excess oil from the cylinder wall. The third ring, known as the oil control ring, regulates lubrication by distributing a thin film of oil while returning excess oil back to the crankcase. In an 8-cylinder engine, there are 8 pistons moving continuously inside 8 cylinders. Since each piston contains 3 rings, the engine typically uses 24 piston rings in total. Every one of these rings must fit perfectly to ensure maximum engine efficiency. The combustion process inside a diesel engine produces enormous pressure. During the power stroke, burning fuel pushes the piston downward. The second compression ring supports the sealing process while controlling oil movement. Its unique profile helps remove excess lubrication from the cylinder wall before the piston moves upward again. This ensures that only the proper amount of oil remains to lubricate moving components without entering the combustion chamber. The oil control ring performs one of the most important lubrication functions in the engine. It consists of 2 thin rails separated by an expander spring. As the piston moves, this assembly scrapes excess oil from the cylinder wall and directs it through drainage holes in the piston back into the crankcase. Proper oil control minimizes smoke, reduces oil consumption, and protects the engine from carbon buildup. Modern heavy-duty piston rings are manufactured using highly specialized metallurgy. Engineers select materials that provide strength, flexibility, wear resistance and excellent heat transfer characteristics. Cast iron remains popular because of its natural lubricating properties, while alloy steel offers superior durability in high-performance diesel engines. Advanced coatings further improve piston ring performance. Chrome plating provides excellent wear resistance and corrosion protection. Molybdenum coatings offer outstanding lubrication under extreme temperatures. Plasma-sprayed coatings increase hardness while reducing friction. Physical vapor deposition, PVD coatings provide exceptional durability for engines operating under the most demanding conditions. Precision manufacturing is essential because piston rings must maintain exact dimensions. Even microscopic variations can affect compression, oil control, and engine efficiency. Manufacturers use computer-controlled machining equipment to achieve extremely tight tolerances before every ring undergoes rigorous inspection. Cylinder walls are finished using a honing process that creates a fine crosshatch pattern. This texture retains a thin oil film that lubricates the piston. The oil control ring consists of two thin rails and an expander spring. Its primary job is to regulate the oil film on the cylinder wall. Too much oil enters the combustion chamber, causing blue exhaust smoke and carbon buildup. Too little oil leads to excessive friction and accelerated wear. Maintaining the correct oil film is essential for long engine life. With the old rings removed, the piston ring grooves are cleaned thoroughly using specialized groove cleaning tools. Hardened carbon deposits are carefully scraped away without damaging the piston itself. Clean ring grooves allow the new piston rings to move freely and expand properly during engine operation. Once cleaning is complete, every groove is inspected for wear. Excessive groove wear can prevent new rings from sealing correctly, even if the rings themselves are brand new. Measurements are taken using precision gauges to verify that the groove dimensions remain within the manufacturer's specifications. The cylinder walls are then inspected. A healthy cylinder should display a visible crosshatch pattern left by the honing process. This fine pattern retains a thin layer of engine oil, providing lubrication while helping new piston rings seat properly during the break-in period. Deep scratches, scoring, or excessive wear would require additional machining before reassembly. Ring end gap measurement is one of the most critical inspection steps. Each new ring is placed inside its cylinder and squared using the piston. A feeler gauge measures the gap between the ring ends. If the gap is too small, the ring ends may touch as they expand under heat, causing severe engine damage. If the gap is too large, compression will escape past the rings, reducing power and efficiency. Every ring is checked carefully to ensure it meets factory specifications. The side clearance between each piston ring and its groove is also measured. Proper side clearance allows the ring to move freely while maintaining an effective seat. In the end, the heavy-duty 8-cylinder truck engine has been successfully restored with a brand new piston ring set. Every piston has been carefully inspected, cleaned, measured, and reinstalled with precision to ensure maximum compression and reliable performance. With the new rings properly seated, the engine is now ready to deliver improved power, better fuel efficiency, reduced oil consumption,